Okay, now we discuss for question number 3 about the concentration cell. The question here is that there is a concentration cell made from ion silver at 25 degrees, and in both the cathode and the anode, the concentration of silver ion are 0.01. So the concentration are the same, right? So if the electric potential at standard condition of the E naught is the same because it's a concentration cell, so the E naught is 0, and if the concentration of the silver ions are the same left and right, on the cathode and the anode, it means that there's no driving force for the cell. It means that the cell will also be 0. The cell will be 0. Okay, because of the same. If you have the same concentration, does you mean you have the same activities, both on the cathode and the anode. So we can elaborate this as in the following. The anode reaction will be silver being oxidized on silver ions, and cathode silver ion will be reduced into silver metal. And in this case, because of the same half cell reactions, they both have the same E naught, right? This is for reduction, right? This is directly from the table, reduction. Okay, so then because the for a concentration cell, right, the idea is to have a different concentrations of the ions, of the silver ions, the ions that is going through reduction and oxidation. So this is the net reaction. So the E naught of the cell is E cathode minus the E anode, because they are the same, so they will cancel out, they become 0. If you go to the Nernst equation, right, always go to the Nernst equation to easily see what's going on and when you change something in the cell. So the E naught of the cell will be 0, the N will be 1 electrons, and the Q would be the activity of the silver ions on the anode over silver ions on the cathode, right? Now when you have the same concentration on the cathode and the anode, the activity will be the same, right? They are the same number of ions in the cathode and anode container. So then activity will be the same, concentration will be the same, so it will cancel out, and this term will be 0. So the E cell will be 0. That's the question. That's the answer for number 3A. From 3B, the question is what happens if you add 0.5 molar of sodium nitrate solution into the anode, right? So you add more ions into the anode. So I wrote here no reaction taking place between silver ions and nitrate, right? So you're just adding more ions into the anode container, just more ions. So you learn from chapter 10 that when you have more ions, then there will be more ion-ion interaction, and that would change the mean activity coefficient. Okay, so activity equal to concentration time mean activity coefficient. So if you change the mean activity coefficient in the anode, then you will also change the activity of silver ions in the anode, right? This remains the activity on the cathode remains the same. The activity of the anode is changing, right? So how does it change? So when you increase the number of ions, then you will decrease the gamma mean activity coefficient. So when gamma decreases, this term will decrease. So if this term decrease, so the ln term will become more negative, and negatives times negative will be positive, right? Okay. So then as you put in more ions into the anode container, the E cell will gradually becomes positive. Now you have a driving force by just changing the environment of the silver ions, right? So the driving force for this electrochemical process in the concentration cell comes from simply changing the ionic strength in the anode container, right? You increase the ionic strength, when you increase the ionic strength or the number of ions in the anode container, you decrease the gamma. As a consequence, you build up a potential because there is now a driving force from the cathode to the anode.